Alright, welcome back you guys to your favorite intermediate algebra course. Today we're going to look at some measures of central tendency. We're going to look at some statistics, common statistics and statistical graphs. So um, let's take a look here and remind you of your mean, median, and mode. Okay? And then we're going to go ahead and draw a box and whisker plot. So let's imagine we have these quiz scores here. 1, 1, 6, 7, 7, 8, 8, 8, 9, and a 10. Okay? Well, if you remember, the mean is like your average, your median is your middle one, and your mode is the one that happens most often, MO, most often. You know, and if you forget that, you can sing the old common rhyme, row, row, row your boat. And here's how it goes. I can't believe I'm going to do this. Mode, mode, mode the most, average is the mean, median, 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 always in between. Mode, mode, mode the most, average is the mean, median, 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 always in between. All right, so there you go. That's how you're going to remember this, okay? So let's take our mean first. Let's take a look at that, which is our average. So we're going to go ahead and sum up all these numbers. And then we're going to divide that. And how many numbers do I have? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like I got 10. So I add those all up, and it looks like I get 65, I divide that 65 by 10, I get 6.5. So my average, I'm going to denote it just like that. My average is 6.5, X bar there, the line on the top there. Okay, my average is 6.5. Okay, let's do our median next. So the median, in between, right, middle, median, middle. So you go ahead and you take your 10 numbers, and I like to cross out top and bottom, right? Let's do the next ones, top and bottom, as I'm looking for the middle one. Top, bottom. Bottom, top is what I should have been saying. And then you're like, wait a minute, I got 2 in the middle. What do I do here? You find the average of those 2, okay? So if you have 2 numbers in the middle, such as this case, for the middle number, since there's 2 of them there, you're just going to have to average those, okay? So you get the old 15 divided by 2, which is 7.5. So 7.5 is our median here, okay? Mode, most often. Mode, most often. Which one of these numbers shows up the most? Looks like we had 2 7s, but there's 3 8s, so 8 wins, right? There's 3 of those numbers. Okay? If they have the same amount, you list both numbers. If there would have been 3 7s, I'd have wrote, well, 7 and 8 are both my mode here. But again, 8 wins out, you got 3 of those, so most often, okay? Now let's extend this a little bit. Now we're going to look at this from a box and whisker plot, another measure of central tendency here. For the box and whisker plot, if you guys remember from a few years ago, you're going to need, let me write these numbers again, 1, 1, 6, 8, 9, oops, that's a 9 and a 10, okay? First thing is you want to look at what's my minimum number, okay? And then the quartile one, the lower quartile, you're going to need your median. You're going to need your third quartile number, and then you're going to need your max, okay? Of course, we already know the median is 7.5, okay? So what's our minimum? Well, our minimum's that 1, right? Minimum is the 1 there. Our maximum number there is the 10. That's the highest score that we have. And then the first quartile. Now, you notice when we did this, when we found the median, it was between 7 and 8, right? You remember that? So go ahead and you put a line right where the median is. Now, if you have an odd amount of numbers and you're doing this, let's say you do that and you find your median, go ahead and cross out the 3 in the middle. And then when you're finding the lower quartile, oops, let me add some here. And then when you find the lower quartile, you're going to find the median of the lower half here. Okay, so for this one, let's go back to the original. Now we're looking in here for the median, okay, in this lower half. Okay, so 1, 1, 6, 7, 7, so low, high, low, high. Oh, there it is. 6 is my first quartile, okay, the median of the lower amount. Whereas if you'd have done it over here, what would have, if you're crossing out that 3 because you have an odd amount of numbers here, and it looks like 1 would have been your median. That would have been your quartile 1 in that case, okay? It's a little different if you have an odd amount compared to if you have an even amount. Okay, well, we need the third quartile, so let's take the median of this upper half here. Low, high, low, high. Hey, there it is. Perfect. It's an 8, right? And if you have an even amount of numbers on the lower and the upper half, again, and you have two numbers in the middle, you would just find their average as well for the quartile 1 and the quartile 3, okay? And then we draw the old box and whisker plot. So let's do the old number line here. 1, okay, let's put the endpoints here. My lowest point, my minimum, put the minimum on there. Go ahead, put your maximum on there. Let's draw the line for the median is 7.5, so that's the median spot. And then the quartile wants 6. Let me put the 6 on there. Let me put the 8 on there, and then I draw this box. Okay, whiskers over here. Okay, so there's your box and whisker plot. And you know, for your data sets, this is kind of nice because it can kind of tell you, hey, look between 1 and 6, right? That's a fourth of your data there. Okay, so right in here, you're like, that's a fourth of my data right in there, right? This is a fourth of my data. That's a fourth of my data in there, and that's a fourth of my data, if you will. Or between 8 and 10 is half my data, and so on. Okay, so those are nice. Useful ways to look at some measures of central tendency, and that's about all we hit on for right now. Now let's talk about range, finding the range. The range equation is just your maximum minus your minimum. So let's go ahead and find your range for this same data set. Okay, there you go. My maximum is 10 minus my minimum, which is 1. So my range here is 9. It ranges 9 here. The data ranges 9 units. Okay, and then you see that sigma right there? This is sigma. Okay, this is one of the notations for the standard deviation when you have all the data sets, okay? When you have all the data, I'm sorry. Not for a sample, I should say. Okay, so this is a sigma here. And there's your equation, okay? So let's talk about that equation. X subscript 1, this is your x1, here's your x2 data, x3, and so on. This is your 10th number right there, okay? So you notice right here, xn, okay, I've listed all my data. You see it there, 1, 1, 6, 7, 7, 8, 8, 8. Anyways, and then we're going to, right here, you see how I'm going to find the difference between, so right here, I'm going to find the difference between 1 and my average. What was my average? 6.5, okay? So 1 minus 6.5, you see how I did it over there in the table? Okay, so right here, 1 minus 6.5 is actually negative 5.5, right? So I'm going to find that, negative 5.5, and I'm going to do it again, right here. 1 minus 6.5 is negative 5.5. And now I go 6 minus the average. 6 minus 6.5, negative 0.5, and so on. Okay, so I'm going to find all those. And then what we're going to do, you notice that the equation says add all those up. Add those numbers up. Okay, and that's going to be your numerator after you've squared each one. Okay, after you've squared each of those, then add them up. Okay, so I take that negative 5.5 and then I square it. There it is, 30.25. Okay, take the next one, which is negative 5.5, square it, 30.25. Take the next one. Remember, we had 6 minus the average. 6 minus 6.5 is negative 0.5. Negative 0.5 squared, 0.25, and so on. Let's go down like to 8. Right here, 8 minus 6.5, 1.5. 1.5 squared, 2.25, right? Okay, so I got all these. And again, I circled the wrong one when I said add those all up. And then I total all these puppies, okay? That's my numerator. Total all those numbers, and that's where you get the 86.5. Okay, so that's where this equation comes from. for the standard deviation. So the square root of 86.5 over n. N is the amount of data points I have. So I have how many data points? 1, 2, 3, 4, 5. Anyways, I got 10 of these total, don't I? 10 of those total. Okay? So square root of 86.5 divided by 10. And that's a standard deviation. And the standard deviation is telling you what's the average deviation, the average distance between each data set, each data point, I'm sorry, and the mean. Okay? That's what a standard deviation is. It's your typical difference between the mean and a data value, right? So if you look at like 1, the difference there between that and the average, 1 minus 6.5, that distance is 5.5, right? And the next one's distance 5.5. Next one's difference there is 0.5, 0.5, 0.5, 1.5, 1.5, 1.5, 2.5, 3.5. Anyways, it's taking the average. That's why you're wanting to square it, because the actual difference is, for the first one, is not negative 5.5. The average distance there is actually 5.5, right? So you have to square it, and then you kind of have to undo that, if you will. That's kind of what this formula is doing. And then average it out. So we divide by 10, because there's 10 uh, data units here. Okay, so you take that square root. So 2.941 is the average distance that each score is from the mean, from the 6.5. Okay, so if you have like a very small standard deviation, let's say our standard deviation is like 0.5, that means all the scores are really clustered together around 6.5, around that mean, around that average. Okay, so that's how you want to look at that. Let me do a quick calculator on the TI-89 and show you how you can do that on that equation on a calculator real quick, and then we'll take a look at that in class.